Hey guys, what's up everybody? Welcome or welcome back to the Apex Academy of Mathematics. We're learning the language of the universe begins here. On this channel, we break down your fundamentals, we rebuild you, and we unlock that genius that lies within you. My name is Akin, otherwise known as Apex LNU, and in this video, we're going to be talking about two very basic concepts. However, it is two concepts that most persons simply just accept as being a law but never understood why it is what they say it is. All right, and these two laws, as you can see here by the demonstration on the screen, is that we're going to be talking about understanding the division by zero and why its result is undefined, as well as we are going to be talking about the zero property law of indices. So let's jump right into the video. Now, if this is the first time that you are on my channel, please, of course, do me the great pleasure of hitting that like button, turning on your subscription button also, and of course turn on your notification bell for future updates and tutorial videos. All right, good. So let's jump again right into the video. All right, so we're first going to talk about understanding the division by zero and why the result is undefined. So of course, please take a look at this video that I have attached to this overall demonstration here for you. So take a look at that, okay? So here's why dividing by zero is regarded as being an undefined value, or perhaps I should say it is such a large value that we cannot state that very exact number, because as you approach closer and closer and closer to zero, then the outcome or the quotient is getting larger and larger and larger. So this result is approaching infinity, which is basically a concept that we use to define the largest number that is in existence. So here we're going to start by using a very simple number. Say for example 10 divided by 9. So 10, let me see if I divided by 9, okay, and we get 1.1. Now I'm going to decrease my divisor here to 8. Notice that this result here is 1.1. So if I'm to say 10 divided by 8, notice that the outcome increases from 1.1 to 1.25. So the value is going up. Very small, but it's actually going up. Now I'm going to skip from dividing by 8 and now dividing by, say, for example, 5. So let's say 10 divided by 5. And now our value has increased from 1.25 to 2. Okay, let's then go ahead now and say 10 divided by 2. Our value will now increase. Oops, that's not 2, but that's 10 divided by 2. And our value has increased to 5. So notice here that our value is moving from 1.25, it's increasing to 2, increasing to 5. So there's an exponential growth in terms of the result. It's moving slowly, but it's still growing. Now, let's say, for example, we have 10 divided by 1. And we got 10. So that value has now increased, right? As you can see here. Now, what we're going to do is that we're going to flirt with numbers that lie between 0 and 1. So we're going to start by saying 10 divided by 0.1. That's 100. 10 divided by 0.01. That's 1,000. 10 divided by 0.001. That's 10,000. So as you can see, that the more digits that we add before this one is the closer and closer and closer we are getting to 0. But this value is increasing exponentially. So if I were to say, for example, 10 divided by 0.000000001. You can see here that this here is, I guess you call this number, well, I don't think this is 9 zeros, this is 1 billion. This is 1 billion. But what I noticed here on the calculator screen, as I was using it, because I'm using a scientific online calculator app, is that notice that the amount of zeros that I am pressing at the same time, there's this thing that keeps popping up, complex infinity. So 10 divided by 0.0, look at that word that keeps popping up on the screen, complex infinity. It means that the more zeros I add to the result there, if I approach closer and closer and closer to zero, the result is going to be extremely so large that not even a supercomputer will be able to, well, I'm assuming that the only device that will be able to record this result would have to be a supercomputer. And that is way beyond human capability to define. So we see that the result is infinity or complex infinity, or is simply undefined. And that's the reason why dividing by zero is an improbability. Alright guys, so happy that you were able to take the time out to get that concept and understand why division by zero is of course an undefined quantity. So I do hope that you got that clear. Alright, so now we're going to jump into the final part of this video. We're going to be talking about the zero property law of indices, and of course why it's equal to 1. Okay, good. All right, so let's get into it. So let's recall what the zero property law of indices states. It says that here that if any number raised to the power of 0 is equal to 1, that's what the zero property law of indices states. So we're looking at saying if a is raised to the power of 0, then the result is 1. Or if it's a number raised to the power of 0 is equal to 1, or if it's a fraction, let's say 2 over 3 raised to the power of 0, the result is always going to be 1. Alright, and it's such a very straightforward concept that most persons say, oh, okay, once I see this, I know the result is 1. But many students never really ask why. Okay, never ask why is it that once you raise a number to the power of 0, it's equal to 1. Some person will often say, hey, any number raised to the power of 0 is 0, or because you're often told that any number multiplied by 0 is 0, but they are not the same concept. All right, so it's very clear that you understand that multiplying by 0 is not the same thing as raising a number to the power of 0. But let's understand why is it that raising a number to the power of 0 is 1. Okay, though to prove this, we are going to have to use the division property law of indices to prove the zero property law of indices. And let's just recall those two. Let's recall that law that states that if you have two exponential quantities and they have the same base, as long as you're dividing them, then the result will often have you subtracting the powers. So here we have a to the power of m divided by a to the power of n, and that will cause us to have to say a to the power of m minus n. Alright, so if we have, say for example, 2 to the power of 5 divided by 2 to the power of 3, then that will cause us to have to say 2 to the power of 5 minus 3, which is equal to 2 to the power of 2. Okay, so if that's the case, then we're going to look at what is the value of 4 over 4. Okay, and if you ask any student, anyone, most persons, whether it is that you are doing math or you hate math or you love math, most if not everybody will know that 4 divided by 4 is actually equal to 1. But no one ever truly questioned why, or not even to say question why, but what's the proof behind this? Alright, and there's a very basic understanding of why 4 divided by 4 is 1, because given a quantity without having a visible exponent, then we know that the exponent that is understood is a 1. So what I'm trying to say is 4 over 4 can be written as 4 to the 1 divided by 4 to the 1. Now, we already got the understanding that 4 over 4 is actually equal to 1. But let us prove that we can get the value of 1 using a different technique. So since 4 over 4 is equal to 1, then I can rewrite 4 to the 1 divided by 4 to the 1 as being equal to 4 to the 1 using a division sign instead, 4 to the 1. Yes? Now notice clearly here that the 4 to the 1 divided by 4 to the 1 here actually visualizes, and it looks like this law right up here. Okay, it looks like this law here. So we can use this law, a to the m divided by a to the n, and we can subtract the powers. So basically 4 to the 1 divided by 4 to the 1 is actually equal to 4 to the 1 minus 1. And we know that 1 minus 1 is actually equal to 0. So that's 4 to the 0. So in conclusion then, what we're saying is that if 4 over 4 is equal to 1, and also 4 to the 1 divided by 4 to the 1 is actually equal to 4 to the 0, if both expressions are the same, but we're getting two different results in appearance, then it would safely say that 4 to the 0 must be equal to 1. And that's the reason why any number raised to the power of 0 is equal to 1. You can try this for yourself with any numbers, 8 over 8, 10 over 10, 5 over 5, a letter over a letter. It does not matter. You're always going to get the result to be 1. Alright? So, hope you guys got that concept and you have an understanding of why division by 0 is equal, well, not division by 0, but raising a number to the power of 0 is equal to 1. Alright, so do take care, and I'll see you next time in another video tutorial. Take care.